Weak acids can be titrated with weak bases and weak bases with weak acids. It's much less common that we'll have to do a calculation on this, but all of the concepts still hold true. So we have a lot of the same features. We don't start as low or high in terms of our pH. Our pH change still has a buffering region with little change in pH, so not as steep of a change. We're not going to see a large vertical jump in terms of the equivalence point, but we're still going to see an inflection point. It's still the steepest place is the place where we get our changing from the acid being excess to the base or from the base to the acid. The pH at that equivalence point could be equal to 7 if our acid and our base are exactly equal in their weakness or in their strength in terms of Ka and Kb. But it could be above or below, depending which one's a little bit stronger than the others. So it's got a similar look, but it's not something we have to worry a lot about. If you are presented with this, know that there are a few things you can still be asked about without having to think about the challenges of understanding the weak with weak. First of all, the initial pH is just talking about a weak solution. So that doesn't actually involve a lot of the titration and isn't any different or harder. The half equivalence point, pH still equals pKa. And in terms of the equivalence point, you probably wouldn't be asked for the pH as to why or where, although that's not something that would be too different or challenging. But we do need to remember, and this is where we can get tricked by something that's very easy, is that even though everything's weak, it's still stoichiometry. The moles of acid are equivalent to the moles of base, or moles of acid equals moles of base. So we can think of that in terms of molarity and volume to get to moles, and then solve for whatever we don't know. Even though everything is weak and we want to think equilibrium, remember the reaction of an acid with the base is always stoichiometry.